All right, good day, everybody. Wherever you are, I'm so happy and I'm so excited to be bringing this to you. It's a very, very big package from CMRC, Creative Mind Real Concept. And I'm most privileged to be the innovator, the initiator of this program. It is a very, very big success to bring this to you. Free Success Project 2025. And this year, I am so happy. We have amazing facilitators, persons who are selfless, who are passionate, who are explicit in every ramification of their discipline, and they will blow your mind. So I want you to keep your tabs and start watching these videos and get excellent results and come back to tell us, and we'll rejoice with you. God bless you.
Good afternoon, everyone. My name is Ogunleye Miracle, and I'm with Creative Mind Royal Concept, and I'll be taking you physics. I'll be talking about motion, which is, I think, the main topic under the aspect of physics called mechanics. So, what is motion? I want to believe you guys understand motion, like it's something that I've been talking about from your SS1, but let me just give you a brief definition. Motion is movement, generally. It is when an object tends to move from one particular position to another position. But it is also time dependent. So if I'm to put it together in a kind of a normal definition, I would say it is the motion of a body from one point to another point, which we refer to as position, during a particular period of time. So let's not waste time on that. Let's go to the types of motion, which we have. We have random motion, which is motion of a body without a specified direction, that is different direction, like motion of football players on the field. Then we have what we call transitional motion, which is what we'll be talking about mostly here. That is motion of a body on a straight line, which I can also call it linear motion. We're talking about it very soon. Then we have what we call the rotational motion, where every part of the body is moving in concentric circle about a fixed point. Then we have what we call the oscillatory motion, the to and fro one, the periodic. But let's quickly go to what we call linear motion. Now, this is where Jamb is going to ask questions from. Your UTME exam is going to be coming mostly from linear motion, free fall, then projectile most of the time, then probably a little bit of simple harmonic motion. But this part is something you have to know. I'm very is not something that I'm doing that it will definitely come out. Are you getting it now? So now, under linear motion, we have concepts like distance, we have displacement, we have acceleration, we have velocity, we have acceleration. And I want to believe you guys understand what we call distance. Distance is the gap between two positions in space. We now have another one that we call displacement. Most of you will be like, distance, displacement, are they not the same thing? No, they are not. One is a scalar quantity, the other is a vector quantity. You may be like, okay, I know scalar quantity, I know vector quantity, fine. But the main difference between them is that one has direction, the other does not have what? Direction. Distance does not have direction. For example, I want to leave the house, I can tell my mom that, Mommy, I'm going 20 meters. The next thing your mom will have to ask you is that, 20 meters in what direction? So if I tell my mommy that, okay, I'm going 20 meters to Tolu's house, that means I'm telling her my direction, and that is my displacement. But only I'm going 20 meters is distance, but I'm going 20 meters in the north direction, in the south direction. That is what? Displacement. Now, moving from displacement, I will go to what we call velocity. Velocity, okay, before I go to velocity, let's talk about speed. Speed and velocity is just like distance and displacement, the greatest of the two. But speed is scalar, that is, no direction is involved. Velocity is what? Is vector, where direction is involved. Now, I get my speed by doing the ratio of the distance covered to what? To time taken. That is, speed is equal to distance covered over what? Over time taken. Why my velocity? Velocity is equal to displacement over what? Over time. Now, you see the difference? For speed, I'm talking about what? Distance, Abby. But for velocity, I'm talking about what? Displacement. Telling you that this is like the scalar form of this. Just the way distance is the scalar form of what? Of displacement. You know, when I was explaining distance and displacement, I said one is moving 10 meters, the other is saying 10 meters in so direction, Abby. So the only thing that differentiates distance and displacement in that part is the direction, Abby. Now in this place too, the speed and the velocity, they are like most of the time they are almost the same thing. They are the same in terms of magnitude, that is maybe 20 meters per second, 20 meters per second. But what differentiates them is also the direction. So if I can say that, okay, I'm traveling at 20 meters per second, fine, that is still my speed. But I'm traveling at 20 meters per second in Shokoto's direction. That is what? Velocity. That is velocity. Now, there's now another thing that makes them to be different. It is not every time that your speed and your velocity will be equal in magnitude. Now, let's say I have, maybe I'm moving at a particular, like, let's say, look at the diagram I want to draw on the board. See something now. I'm going like this. I start from this point A, going to another point B. Now, in this direction, just one. If this place to this place from point A to point B is just 10 meters, and it took me like 20 seconds to cover the whole journey, I can say that for this straight journey from point A to point B, my speed and my velocity is the same thing. Why? When I do the calculation, I will get what? I will say I have what? 10 meters, that is my distance here is what? Is 10 meters divided by what? 20 seconds, which I will have 0.5 meters per second. For my speed. For my velocity, it will be the same thing, which is still the same displacement. My displacement in this sense is also what? 10 meters. And it's also taking me what? 20 seconds, which will be what? 10 meters over what? Over 20 seconds. And that will still be 0.5 meters per second. That is the first case. But what if I have something like this? What if I have something like this? In a case where I move from point A to another point B, like this initially, then turn back, like probably move another distance to this side, maybe to another point C, like this, then go back. In fact, let's not move to that part. We're kind of moving fast. Let's do something simple. To point B. Now, from this point B again, and I moved back to like a point in between A and B. Let's assume from point A to point B now is what? Is 10 meters. Now, from point B to this new point C, in the middle part of A and B, let's assume that one is 5 meters. I am now asked to calculate my speed and my what? And my velocity. If I'm calculating speed, I said speed is what? Distance covered over what? Over time taken, right? Now, what is my speed in this case? My speed will be equal to the total we take displacement over what? Over time taken. Now, see something. What is my displacement in this case? This is the first part. I move to this part B, then move from part B, the same straight line, no, but in the opposite direction to this point. What is my displacement? I know some of you will be like, is it not the same thing as the distance? It should be 15 now. No, it is not this. It's not 15. It is what? 5. And how do I get my 5? See, the first journey is to the right, Abby. Let's assume if you are using your what's it called, vector quantity, we can use our cardinal point to represent. If it's moving to the right, I can say that is what? That is plus what? Plus 10 meters. Now, if it's not moving to the opposite direction, which is the negative, I can say this is going towards the negative, and that will be what? Minus 5 meters. Now, that will now give me a displacement that is equal to what? 5 meters instead of what? 15. Now, to now not make it complex, you can assume that your displacement is the distance or the gap between the initial position and your final position. Now, this is something. When the journey started, I went to this part, then ended up stopping A, B. That means this is my initial position, this is my final position. If you look at the distance between the initial position and the final position, what is it? It is what? 5 meters, not 15. But the total distance I covered is what? Is 15 meters. But if I were to look at the initial position and the final position, it is just what? 5 meters that's in between the two of them. So that means my velocity will be what? This 5 meters, which is for the displacement, divided by what? By the time taken, which is still the same thing, 3 what? 3 seconds. So 5 divided by what? By 3 will give me what? 1.167 what? Meter per second. Now look at it. The speed is 5 meters per second. The displacement, the velocity is what? 1.67, which is quite different, Abby. Yes. That now solves the second stage that I said. The first stage I said they can be the same value in terms of magnitude. The only difference will be direction. But now, I'm talking about it in terms of both magnitude and what? And direction. The speed is 5 meters. The velocity is what? Is 1.67 meters per second. Now, I'm talking about velocity. I'm supposed to add direction too now, in case they ask, but most of the time they will not. But if they ask, if I'm to do this in terms of your compass now, your north, south, east, and all this thing, to this side is what? Is east, Abby. Then to this side is what? Is west. Now, where is my final direction? My final direction is towards this side, right? Like, towards this side. Then my initial direction is towards the eastern side, Abby. Yes, but what is my resultant direction? Resultant direction will be in direction whereby I have the longest distance or the longest displacement. Now, in this side, I have 10 Abby to the east. Then I have just 5 to the what? To the west. So my resultant direction is going to be what? It's going to be, what is it called? It's going to be 5 meters in the what? In the eastern, in the eastern direction, because that is where majority of my displacement is what? Is focused on. Or that's where I have higher displacement. Therefore, my velocity will be in that same direction. It will be 1.67 meters per second in the western direction. So, if that one is clear, we can just move towards what we call acceleration. Acceleration is actually not hard. It is the ratio of what? Of the velocity to what? To the ratio of velocity to time taken. Acceleration is the ratio of what? Velocity to what? To time taken. Now, there are some things I want you to take note here. We can have you have two major things they can ask. They can ask you for the acceleration normally, which can also be equal to the average acceleration. But there are sometimes they will ask you to calculate the instantaneous acceleration. Even for velocity, they can also ask you to calculate instantaneous. But one thing that makes it different from the normal calculation is that whenever they are referring to instantaneous, they're asking you that at that particular instant in time. And the trick is, most of the time, is usually what? Differentiation. So let's assume they give you a question like, they say, okay, the velocity of something is represented in form of let's say t squared plus 2t minus 1. And you ask you to calculate your acceleration. Just calculate acceleration. Without telling you, just know that it is what? It is instantaneous. But be very careful. Look at the context of the question. Is it instantaneous or is it average acceleration? If it is instantaneous acceleration, all you have to do is what? Differentiate. And when you differentiate, your instantaneous acceleration at an instant will be equal to dv dt. And when you differentiate this, I want to believe that you people know, at least you understand calculus, that'll be differentiation. So when I'm differentiating this, I'm having what? 2t plus what? Plus 2. And how do I do that? This is having a coefficient of 1, right? So 1 times 2, that is 2. Then t raised to power 2. I will have to subtract 1 from the power. So if I subtract 1 from the power, I'm going to have 1 remaining here. That's an invisible 1, right? Now, for this place, I'm having 1 initially. So 1 times 2 is giving me 2. Then t raised to power 1. If I subtract 1 again, that will give me t raised to power 0. And any t raised to power 0 is what? Is 1. So 2 times 1 will give me what? Will give me 2. So this will be my what? This will be my instantaneous acceleration in meter per second square. But is that the final answer? If you now look at the question very well, they will now tell you that at maybe 2 seconds, at 1 second, let's use at 1 second. At 1 second, that means when t is equal to 1 second, my instantaneous acceleration will be equal to 2 open brackets 1 plus 2, which will be 2 plus 2, and that will be what? 4 meters per second square. That is for that. But what if you are asked to calculate your average acceleration? How do we do that of average acceleration? This is it. For average acceleration, this is what you do. For average acceleration, the trick is that they will give you 2 different times. They will tell you that, okay, calculate the average acceleration between maybe t equals to 1 second and t equals to 4 seconds. If it is like that, that means you are going to get your velocity in 2 different times too. Let's say, for example, our t1 is 1 second, our t2 is 4 seconds. Now, for average. Now, that means I have to calculate my velocity when the time is 1, and I will calculate my velocity when the time is what? Is 4. So for when the time is 1, that is, I will substitute it directly into this. I'm not differentiating for average. I'm not differentiating. So I will substitute into this. I will get what? 1 square plus what? Plus 2 times 1 minus 1. So 1 square is 1, I'll be plus 2 minus 1. That will give me what? 2. Now, for when it is 4, that will give me 4 square plus what? Plus 2 times 4 minus 1, which will be what? 4 square is 16. 16 plus 8, that is 20 what? 24. 24 minus 1 will give you what? 23. Don't forget that this is in meter per seconds, meter per seconds. Now, for me to now get my acceleration, my average acceleration, remember, is then from instantaneous what? Acceleration. I will now say that my average acceleration is equal to what? Is equal to V4 minus V1 over what? Over T4 minus what? Minus T1. And what is my V4? That is 23 minus what's V1? 2 over what? What's T4? That's 4 minus 1. And that will give me 21 over what? Over 3. And that will be 7 meter per seconds square, which is different from the value you get if you do instantaneous. So I think you have gotten something. Let's move to, okay, there is one more thing I want to add. They don't usually ask, or once in a while, they might ask. After acceleration, someone will be like, okay, we started from displacement. From displacement, we get our, what's it called, velocity. From velocity, we get acceleration. Can we get some other things? Yes, you can get some stuff like Jones, you can get jerk, but not really compulsory. So don't waste your time on that. Then we move to 4. Under linear motion, we also have what we call the equation of what? Of motion, which is what most of you usually know now. But let's sharply touch it, then we touch the graphical part, then we'll move to 4 in the next video. Thank you.
Be sure to link up with us, message us, seek out for our email, send us messages for further questions and mentorship after you have seen these videos. I'm very happy to say this again, that it's a time for you to move on and succeed. It's a free success project 2025. Bless you everywhere that you are. Again, my name is Emmanuel Aderoju Adeyemo from Creative Minds Concept.